All right. So yeah. So let me go through your answers. Has anybody else attempted this one? I could not. Could you can you paste your answer again if you have typed earlier? Yeah, this the one. So here. So the mapper is key and word. Okay. Key. So key tab word and the value is this. And first reducer is key and next word aggregated value and second reducer is so there can be only one reducer, right? Okay, good, good. So let me explain what I have understood. So in this, what you're trying to do is you are creating a composite key of word and next word as the word and the next word as the key, and value is next word dash one. Okay. Now in the reducer, the word and next word composition is going to give us this. Alright, so how many times the next word has occurred after this you can compute. Good. And once we have done that, we know that which one is more frequent. And under reducer, the key is so your approach is correct, just that in reducer the key would be whatever key you have specified in the mapper actually. Okay. All right. In reducer 2, next word and descending value of oh, okay. Okay, this is the output of the reducer. Okay. So reducer 1 will give out word, all right, and next word. So what is the key? This whole is the value because reducer will give out. Okay. So next word and aggregated value is the value and the word is this thing. Now again you pass through the map reduce phase where there is no map reducer, no mapper, but there is only a reducer. Okay. Okay. And next word. Okay, that is good. That is good. All right. All right. This is good. Anybody else? Okay. So yeah, this approach is correct. Yeah, we can change the key in the next. So basically, he has created three phases of MapReduce. MapReduce 1, okay, where the mapper is creating the. This is our mapper for MapReduce 1, and this is the reducer for the first phase, and this is okay. So what will happen here is it will basically bring all the or tuples, all the pairs of the words together. So if there are happy birthday hundreds of times, so happy birthday will become the key and the value will be birthday 1, all right, and that way we will exactly know that happy birthday has occurred how many times. Okay, so basically it's finding the frequencies of phrase of two words. Okay, finding the frequency of two words phrase in the whole text. Okay, so basically first word, second words, all such combinations is trying we are trying to find out the frequencies of such. This will tell us which two words come together in that order. Okay, come together frequently. And once we have figured that out, we have solved our problem. So basically, it's a word count problem. Good job. Anybody else? Okay. So that was Kalyan's approach. Now let me have a look at Srinivas's approach also. So yeah, Srinivas's approach is split entire data map into first word. Yeah, correct. That's a similar approach. Good, 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 good. That's a good approach. All right. So, all right. So let's have a look at one of the approaches which I'm going to talk about. So this is the most rudimentary, most rudimentary approach. In this approach, so this is our text, and what Mapper did was it broken down a key and value as. All right. I think Manish also has something. Let me also discuss that part. So first job, the mapper is to just clean up the HTML and grab the text. Okay. So this one mapper. So it will be just a mapper, right? It's just a mapper. The first one is just a mapper. Okay, without even sorting. So we can disable the sorting as we had discussed in the last session. Second job is to get the result produced by first job, and here, all right. So this is working fine. I'm just wondering that it might, will it reboot again suddenly? Second job is to get the results produced by first job, add a duplicate word. Example, no big data is okay. Will get converted into no data is new line. Okay, is a leader in training. Perfect, perfect. What he is trying to say is it will get converted into something like this. Perfect, perfect. So yeah, awesome, awesome. So yes, so this is one approach, and other approach is what Srinivas is telling. So in this approach, what he has done is he has taken this text, okay, and first first key is this, and value is. Then in the next line, is the first value, first key, and the leader is the value. Okay, so no big data is the key, and this is the value. This is the key. This is the value. This way, what will happen is all the words that follow no big data will come together. Similarly, all the words that follow is will come together. Similar in this one, all the words that follow lead and so on. Okay, this way we are bringing all the words that follow a particular words together. Okay, basically that particular word is our key, and for each key, all the words that follow it in the huge text that will come together as per this logic. All right, and same thing I'm also trying to do it here. Okay. So how are you, Ram, happy? Happy birthday to you, and you happy new. And in case of year, we'll have to skip it. Note that in this approach, what's happening is we have got how many lines? Four lines. First line, second line, third line, fourth line. And our mapper will get the input line by line from the Hadoop. Okay. Our mapper will get the input line by line. Okay. And then it will process it line by line. And then the result will go to the reducer. So there are multiple challenges in this. Do you see any problem with this? Anyone? This approach, so is the approach clear to all of you? We basically broke down into pair of words which are coming together or which are following each other, and then we are trying to find out, in the reducer we will find all the, so if there are multiple words that follow some word, for example birthday and new are following happy. So in the reducer what will happen is it'll look like this. Okay. Here this data will get sorted first internally. So it will get sorted, and then this will be get grouped. All right. So there is nothing else to group. Yeah. Then under this, if there are, it'll do the computation. And so Manish is saying yes, you miss some of the keys like Ram as you're missing. Perfect. So here, since we are only given one line at a time, since we are given one line at a time by Hadoop, we are not able to pair you and Ram. Okay. Also, we should not be pairing these. This we can avoid anyway because we are given the whole line. We can figure this out. Okay. So the meaning is that instead of processing line by line, ideally we should be processing it either sentence by sentence or e- or paragraph by paragraph. Okay. So correct, Manish. Now we have the key is same. Uh, okay. Will not be able to bring matching values together. Can you explain, Kalyan, a little bit more? I'm not able to understand that. The keys are same. Yeah. Yes. Correct. So birthday and new will come together as the values. Correct. So yes, Mohan's point is that we are we assuming that punctuations are removed. So removing punctuation is itself a difficult thing. So let's assume for this problem that we have removed punctuation in our MapReduce itself. And also we have taken care of cases. Correct, correct. So Kalyan's point is that if there are multiple in this problem as we have shown, happy birthday, multiple happy birthday and happy new year, we have to ensure that they are coming together. That is correct. So the way we will work here is all the words will be aggregated by the first words. So happy, birthday, new, and so on. Now, the computation of the frequency of happy and new will be done by the reducer. Okay. So Hadoop will make sure the MapReduce part component of Hadoop will make sure that all the words that follow happy will come together, and in reducer you will have to do the frequency analysis and then figure out only the top 5 words. Now question is, what are the challenges do you see? One challenge, big challenge we found. Correct. So yeah, Srinivas's question point is reducer has to use again one more mapper like mapping. Yes. So either reducer does it everything by itself in the memory, or it can delegate further. So yeah. So those are few problems. So first is computation of frequency can be further map reduced. Okay. Yes. So in the previous approach, reducer was playing a very big role. And imagine the words like is, am, are, because after is, am, are, or any preposition, there are billions of words that will follow in humongous text. And doing the computation analysis, frequency analysis of billions of words in the reducer is itself such a big headache. And if you remember that earlier we discussed that for each key, all the values are bound to be on the same machine. All the values for a key, all the values for a key are bound to be collected on a single reducer. No many how many reducers are there, no matter how many reducers are there, still all the keys, all the values for a key will be gathered on one node. Alright? Good, good. So we have covered all these 3 points. So the answer to yeah. So answer to your questions, Srinivas. So is the approach which was given by Kalyan, and I think you also. In this, what we were doing is, in that approach, what we were doing, instead of forming key based on these first word, second word, we will make first word and second word the pair as the key, and then find the frequency of those words. So that's one way to do it. All right. And your previous approach is correct. All right. Now, what we are going to discuss here today is that how do we avoid this kind of problems? We do not want to process line by line. We want to process it some other way. Okay? We want to process it paragraph by paragraph. We want to process sentence by sentence. How do we do that? Okay? How do we make that happen? There'll be a lot of problems you will see in future which demand special treatment of input data. Like in this one, the single line which is given at a time by mapper reducer is not the right approach. we should be given one paragraph at a time or one sentence at a time. Alright, so let's just try to see what can we do about it using MapReduce. So Hadoop provides you all the customizations and all the ability to do all of this. So today we are going to get into the details of this one. Alright, quick questions. The data generated by mapper is given to reducer, and so this is a quick quiz. So that, yes, are you able to see the screen and read it? The question is, the data generated by mapper is given to reducer and then it is sorted and shuffled. Yes or no? Correct. Which flag? Alright, alright. That's correct. The answer is no. Okay, got it, Srinivas. So, yes. And so, alright. I think Kalyan means that the flag which says that should we sort a data or should we have the reducer or not. That flag. Yes, correct. So by default, the grouping and sorting is on. We can turn it off when there is no reducer. All right, good, good. So the answer is no. The output of mapper is first shuffled or sorted and shuffled, you can say, and then reducers are called by Hadoop. Okay, so next question is, the mapper can only generate a single key value pair for an input value. Anyone can help me with this? The mapper can generate only one key value pair for one input value, input text or input line or input whatever. Correct. The answer is false, no, or yeah. So mapper can generate as many key value pair as it wants for an input. If you remember, because the important part here is those people who have not gone through MapReduce and who are just trying to figure out the meaning of mapper, they will generally say it is one-to-one mapping. Okay, as in that was a traditional definition of mapping. You run a earlier in traditional terms, like in Perl, there was this function called map, which you apply, which basically applies your mapper code onto an array. What does it mean? It will execute your function on each element of the array. It will take the value from each index, give it to your function as the argument, and whatever is the result of returned by your function will be stored in another array. So that was one-to-one mapping, and that's where lots of people get confused who have not worked on MapReduce per se. All right, all right. So good, good. So all of us are on the same page. Now, next question to you is, a mapper always have to generate at least one key value pair, right or wrong? A mapper always have to generate at least a key pair, a key value pair, at least one key value pair. Do you think it's right or wrong? All right. So, okay, wrong. Why? Because, right? So, if you remember our word count again, it is up to our mapper whether it wants to give out a key value, or it doesn't want to give out a key value, or it want to give 100 key value, or it doesn't want to give any key value. So it's up to our program to decide how many key value pairs it wants. Hadoop does not enforce anything on number of key value pairs we want to produce. Correct? All right, now next problem to all of you is no, no, not necessarily. If there is a line which you think is only full of garbage, you may choose to skip it. All right, you may not generate any key value pair for that particular record. So remember that the input is broken down into lines, and for each line your mapper function will be called, or your mapper command will be called, and that's how it will work. Okay. So when your mapper command is called on each of the line, the Hadoop will expect your mapper command to give out the key value pairs. Okay. Now Hadoop doesn't say that you have to give key value pairs. Okay. The Hadoop doesn't say that you have to give at least one key value pair. No, it doesn't say that. So it's up to your program whether it has found some key value pairs in the input or not. If it has not found key value pairs as per your logic, it will just skip that. All right. Now, next question. By default, there is one reducer. Great. Yes, there is one reducer in case of most of this, but you can change number of reducer tasks by using this variable. All right, now next question is, what is the major role of job tracker? A or B? What is the major role of job tracker? A is executing the map reduce logic. B is delegating the map reduce logic to task tracker. Perfect. Great, great. So all of us are on the same page. Next question is, the map logic is executed preferably on the nodes that have required data. Great, great. So everybody says yes. Yes. Awesome. Two more questions. The map logic is always executed on the nodes that have the required data. Correct or wrong? Awesome, awesome. So this batch seems to be the smartest batch of all, and because most of the people give the answer as correct in this one. All right, so it's a little trick question. Basically, the keyword is always here, and it depends on the slots from the nodes. Awesome. All right, where does Hadoop store the results of reducer? In HDFS or in local file system? Great, great. So Srinivas, the output of the reducer goes directly into HDFS. Alright? That's why, if you remember the part 0, part 1 and all that, basically being generated after the reducer. Alright? So, Srinivas, you want me to explain? Alright, so let's have a look at the diagram again, which we generally refer to. I'm hoping the diagram is there somewhere. It's not in 2, it's not in 3. Let's have a look if it's there in 2. Oh, it's not there in this one also. Yeah, here. Okay, so if you see that the data is loaded as split, and after loading it, it's passed to mapper. Mapper does key value, and then it's sorted, and then those key values is carried centrally to that reducer, the node which is called reducer. And then after merging all of this data on reducer node, your reducer code is called. This is your reducer logic, whatever is your logic, and that logic will convert this input data into something which goes on to HDFS. Okay, awesome. So let's move on. And next question. This is probably a little more tricky. Where does Hadoop store the intermediate data such as output of map task? So if you remember, map task's output is being carried to a central location, and this data which is being generated as the output of map task is the result of the input provided, and would be basically storing this intermediate data somewhere. So is it HDFS, local file system, or memory? hmm Okay. Also note that whenever you put some data into HDFS, those replication factor will kick in, and also the data might go to another node based on the availability of disk space. And this data might be something like few if there are, say, multiple blocks available on the same node. So this data might be little huge, maybe say 500 MB, 200, 1 gigabyte or something like that. Okay. All right. So so the answer is first in the memory and then quickly parsed into local file system, because it's not worth it to keep it in HDFS, because this data will go useless after this process is finished. Individual parts of data which is half processed, it hasn't gone through the reducer, is not of any use in general. So it's okay to drop it after the process has finished. So if you're putting the data into HDFS, it's not worth it, because it's basically going to get replicated, moved to other disk and all that. Alright. So first the data is put into memory, as we whatever keys are being given out by your mapper, they will be collected first in the memory and then will be put onto the disk. Alright, then will be put onto the disk. Moving on. So this is clear to all of us. The whole of HDFS block No, this is basically not for backup purpose. It's just intermediary input. Whatever is being gathered from mapper is being put down into the disk n- because if it tries to put everything into memory, the temporary data, if it tries to put it in the memory, then what will happen is that memory will get full. So what it does is it reads few hundred key value pairs, then purge them into disk, and so on. Alright, so the question here is the whole of HDFS block available on a node is fed to the mapper. Anyone? Yes? No? Mohan says no. Lakshmi. Okay. Okay. Anybody wants to change their opinion? Correct. Mapper logic executed on at a node. Okay. Alright. So the question is whole of the HDFS block is fed to your mapper. Is that correct? So my question, okay, let me ask you stepwise questions. Let's say there is a text file which is having 500 MB, 500 MB, and first block is 128 MB, second block is 128 MB, third block is also 128 MB, fourth block. Now, now think about this situation. In the first block, which is 128 MB, so 128 MB. Imagine, imagine a huge text file of say 200 MB for time being, having two parts, 128 MB, and other part is how much? Quickly, somebody, 72 MB. Perfect. Thank you, Basraj. And now this file, do you think when we say 128 MB, so the te- first block will contain the whole complete line? Don't you think the last line of the block 1 will get cut at certain position? Don't you think so? So that means that last line will become two lines. One line will go to block 2 and other line will go to block 1, correct? And if that is the case, then your mapper reducer, who has been promised that we will give you line by line input, okay? So, okay, let me repeat what I said. So, do you think the last line of block 1 will be complete, Kalyan? Because 128 MB is ruthless and hard. Okay, it doesn't say that cut it at 128 MB or nearby. It doesn't say that. It says that cut the file exactly on 128 MB. Whether this this point where 128 MB has reached, whether it lies in the middle of word or in the middle of line or in the middle of character in case of multi-byte characters, it doesn't matter. It doesn't care about where this boundary is. It will cut it. So it's like this. So let's say it has found that in this line itself, in this line, it has found that the 128 MB is this much. It will just cut it from here. The first block 1 might contain this text, and block 2 might contain this text. You see? Okay? It will just cut it. Correct? Okay? So to compensate this kind of problems, to compensate and solve these kind of problems, Hadoop guys came up with something called input split representation. So input split representation is the logical representation of block. Okay, it can be, so in this input split representation we tell that please give us line by line, no matter how. Okay, so what input split under the hood would do, it'll transmit the last line to the next block, meaning it will transmit the one which is broken here to the next line, and block 1 will contain some other text. Alright, so therefore if it tries to feed the whole HDFS block to your mapper, the data will be incorrect, or you can say partially corrupt. Correct? Because block is like a hard boundary. So answer to this question is yes. What's your answer? Correct. So it's not the whole HDFS block, it's a representation of an HDFS block which is fed to the mapper. Okay, we will talk about it. This boundary data which has been cut at the boundary, it will be moved to another block. Okay, we'll see this how. Alright, is everybody with me on this one? Should we go ahead? We'll go into the details of this particular idea. Awesome. So let's move. So so today we are going to first we discuss the general aspects, and we have understood the value of, we discussed two ideas on the same lines. First was, what if our key and the value we require, they are spread into two lines? Second is, what if the boundary, the blocks are at the point where basically the words are being split, lines are being split, how to resolve those kind of problems. All right? Or how does Hadoop resolve all of those kind of problems? Now, so it's very clear that blocks cannot be fed directly. They have to come through something called some logical representation. Okay, so let's start with MapReduce in Java, and then we move to input split. Okay, so how do you write MapReduce in Java? So how many of you are okay with Java? Nobody? Okay. All right. So here we are. Now, okay. So some of you are okay and some of you are not. So I will go with the basics. So have you actually seen under my courses? Did you see the Java courses? Did you try to follow any of those, or is it not good? All right. So did anybody try to follow? Was it okay, not okay? I'm seeking a feedback from you guys. So give me the feedback, and if you have any challenges with that course, we will try to see if we can make that better. All right. Although it's a complementary course, but still it will be very helpful if it is more user friendly. Okay. All right. Now the question here is, first, why Java? The plain vanilla answer is, since Hadoop has been written in Java, it makes sense to do it in Java. Hadoop was written in Java because of the compatibility reasons. The plan was to basically make Hadoop run on every kind of machines, and that is only possible if we go with something like Java. Now, writing MapReduce in Java is pretty straightforward. All you need to do is install Eclipse. You can install Eclipse going to the website. Just the basic version, Java version will do for us. And once you have done that, you can create a Java project by, so I'm opening Eclipse. I just hope that my machine does not crash because of the, alright, so let me try to pause everything. So So generally this asks for your workspace. Workspace is somewhere where Eclipse keeps all the metadata about your projects, settings and everything. Alright, so here you can create your own project. You can say new project and give the name, select the Java project from here and go to next and give the project and then finish. And once you have finished it, you will get a project like this. Okay, here. So yeah, so, sorry, your project will be empty. Your project will be empty. A better way would be that we have provided you a sample project. You can import that project. You can say click import, and then whatever project is there in the unzip folder, you can basically select that folder and then use it. The way we have selected here, can just say not this way. We can say go to training, and here we can say open, and I'll show you that there is a project here. Alright, so in the same manner you basically download our project from the from the session number. It should be, this is our session number 5, right? Under session number 5 you will see that, under session number 5 you will see that. And alright, so once you have done that, after importing, also make sure that you have added libraries. Libraries are added using, go to properties, right click properties, Java build path, and there you have these libraries. So libraries are also available as part of our project, the one which is listed on the website, and you can use the libraries from that one itself. Under the libs, there is a, all the libs are available. Ideally, you would require only two to three libs, these ones basically, but add all the libraries just to be safe. Okay, so this way you can basically add the libraries here. You can say add jar or add external jar. When you have the jar is package of somebody else's Java code, and basically if you say add jar, the if those jars are available inside your project, you can add them. If those jars are outside your project, then you can use external jar. All right. So either way is fine. And once you've done that, next step would be to start writing MapReduce code. Okay. The other thing is, please change the JDK settings. So it's a general advice. Here you can see the JRE, and just a second. So on this one you have properties. Under properties, we select the Java compiler to a lowest possible compilation level. So right now we have chosen 1.6. The reason is that everywhere it is fairly assumed that 1.6 would be available. So it's safe assumption to go with 1.6. Okay, and the question is, why do we go for 1.6? Or question is, what should be our approach whenever we are writing a distributable code? So when you are distributing your code to multiple users, whether these users are our cluster users, meaning we are deploying our code on a cluster and it would be deployed on multiple nodes, or you are giving your binary to your customers, which they will be executing their own environment. In both the cases, you would what you want to do is you would always want to keep your compatibility at the lowest level. You do not want to be in the scenario where you are telling your customers that can you please upgrade your JRE? Can you please upgrade your Java? Because in case of data centers, or it is not possible to upgrade Java or upgrade any library immediately or overnight unless it's a security patch. All right. So on generally on servers we do not want to upgrade our Java or any other library. So whether you're coding in Java or any other one, you should try to be as much as possible to you should try to be compatible with lowest most version. Okay, maybe a version which was launched 2 years ago. So that kind of version is be to write code against some version which has been launched maybe 3 years ago, it's safe enough. If you try to work with the latest code, latest Java or latest Python, the chances are that your code will not run on the previous version, and therefore your code will be useless. All right. So as a general software practice, you basically compile code to older older JVM. All right. So yeah. Now next step is creating a mapper. All right. So do you want to take a break? All right. So 10 minutes break. Back by at 8:44. Hi, should we start now? Can you hear me? Alright, so here we are. So what we have done is we installed Eclipse by downloading it straight away, and we installed the Java version of the one which is for Java programmers, and then we create a Java project, and then we added these libraries. After that, we basically changed the version of JDK to change JDK from I mean that's okay, and the one which we need is this setting particularly. This is still okay. So Java compiler setting, the output setting we have set. Once we have done that, let's start writing the code. So the first class you will write is the mapper. Now there's a important multiple things in this, okay? And there are multiple things in this. So before you get very confused about this code, let me try to simplify it. Let me try to simplify it. And so what we are trying to do essentially is we are writing a function called mapper, okay, which basically gets key and the sorry the the key values. It also gets a key value, not only input line, okay, and then it returns it basically emits key value. That's the standard syntax of it. Okay, it does some logic, for loop, while loop, and under for loop it basically emits something. Okay, so you might have some I equals 0, blah blah blah, and then you have this. Alright, so this is what is the syntax. And now what is this key and what is this value for mapper? We were told that key and value there we will get the line as the input. So so in Hadoop the mapper also get key value, and by default the key is the byte count byte count. So I'm putting it under comments so that it has no significance. So the key is basically key is byte count. I'll tell you what is byte count, and the value is line. So the value which is given to the mapper is the actual content. Now instead of giving the line number, Hadoop is giving you the the byte count of the line. Okay, which character, which byte it is the line is starting with. Okay, that is the byte count. So you will get line. This is line as the value is line here. Value is a line. You are getting one line at a time in the mapper, and you are going to do something about this line, and at which byte, instead of saying it is nth number of character, we are saying at which byte number it's starting. So you can think of it as at which character number in this whole file our line is starting. So it essentially tells you the overall position of this line in this file. Okay. Using with this, using this key, which is the byte count, will you can do multiple kinds of things. You will know that where are you in this file, okay, and you can do multiple kind of manipulation. You will see it later, and then you will emit some key value, not really the same key value, some key value. All right. So this is the same syntax what we are trying to do here. First, but for this, it's a little more bells and whistles in Java. So first you do is you create a class called stub mapper. So whenever you are creating any program uh, in case of Java, you have to first create a class. Okay, you have to first create a class. Now this class, which is a mapper, it essentially is a mapper because it extends a mapper. Its behavior is like a mapper. So we are saying we are creating a class called stub mapper. You can create your other class, so you can say your own name here and say extends mapper. It should extend mapper, and mapper is the basic abstract class which tells that what should a mapper do. Okay, you are extending its behavior. You are extending the behavior of the usual mapper. Now, how we are extending the behavior of usual mapper? Usual mapper, the general mapper provided by Hadoop, can take any key and any value. But you want to say that my mapper would get object and text as the input key value and will give out text and long as the output. Okay, so here when we are creating our mapper, we are upfront telling that our mapper is going to be a mapper. Stub mapper is a mapper of this kind. This is the data type, meaning in our mapper we'll get object and text as input, and text and long writable will be our output key value data type. Okay, so that's the thing which we have, which Java and C++ have. C++ has something called generics, and this is called templates in case of uh, sorry, C++ had templates, and here it's called generics in case of Java. It basically is saying, it's basically concretizing the base class, saying that our mapper is not generic one. Our mapper is will get this kind of input and will give out this kind of output. All right, and which means that your function will only accept these key value in the argument and will only give out these kind of things in the as the key value. Okay, so this basically defines a contract saying my stub mapper is essentially a mapper who takes this data type as input and this data type as output. It gives out this data type as output. Now then we create our function inside this class called map. Now in the map we'll get key and the value. Okay, same data type whatever we have defined here, object and text, is what we can put in here. Meaning in our mapper we will get these two values as the argument. Now we can utilize these two to do some magic. Okay, now third argument is context. Context is the argument. Context provides you the whole information of current process. Okay, you can see in the context there are multiple kind of variable. I'll show you in the Eclipse. So stub mapper is here. So here the code is visible to everybody. The font is okay. So here you have all the information the configuration, everything is available to you. Alright, so a whole information about the current MapReduce phase is available here. You can do a lot more with context. Okay, but for time being, just understand it's a kind of what do you call it, the conveyor belt provided by Mapper Hadoop to you, on which you have to put your stuff once you are done. The output key value pair has to go on to context, which is, you can think of right now like a big conveyor belt. Whatever you are working upon, you have to put back onto context. So this is what we are giving out. We are saying this is our key, this is our key from here to here, this is our key which we are giving out, and this is our value which we are giving out. Alright? So we are saying context.write, which is equivalent to saying emit. It is equivalent to saying emit, and so we are saying context.write this key, that value. Alright? So we are implementing a function called map. Override is needed because we are basically telling Java that, hey, we are overriding this function. Okay, this helps us figure out that whether the data type is same or okay. Say, imagine that you made a mistake in map function. Instead of overriding, it might have created another function. You will never know. So to be on the safe side, it's good to put override so that we know that we are really overriding or we are not creating a new function. Now, here it's okay. Next is that what is it that we are doing here? Let me just go over that. It's pretty straightforward what we have discussed already. So the value contains our input text. This value is the line. So we do toString over it, meaning we get the string from text, and then we split it by tab and space. We get an array of words. We iterate over one word at a time, and then in the output we give out that word as the key and 1 as the value. You see the 1, and new text word is basically wrapping, creating a class called text which is wrapping around a word. Okay, it's like while giving a gift, you put it in a wrapping paper. Similarly, we are wrapping our word with a new class called text, because that's what the text object is, what context understands. Okay, context does not understand our primitive types. So Hadoop has created its own data types which you have to use for all work, such as text, long writable, and int writable, and all those data types. So we basically put the wrapping paper around our key, which is individual word, and we put wrapping paper around a numeric 1, and we give it to context, and we are done with giving the data to mapper, to the Hadoop. That's correct, Srinivas. So text class is Hadoop string data type, correct? Because they had to transfer a lot of data from one machine to another, and they realized that the primitive type do not do justice to the format of the data, and therefore they created their own data types. So we have to keep on casting, recasting, uncasting, meaning, or you can, if you're coming from .NET background, you can say boxing, unboxing all the time. Putting the variable in the box, wrap it around, and send it ahead. That's what we are doing here. We are saying new text, which means create a new box, put word inside that box, and send it to context. Alright, that's a mapper. Similarly, in the reducer, we extend reducer and specify what all the data types are there. And also note that these data types are going to be same as the output data type of the mapper. So text long writable and text long writable. Okay, because whatever key value pairs you provided in the mapper, same kind of data type will be given to the reducer. So what do we get in reducer? We get key and array of values. You can think of this as a big array of values. We get a iterable, we get a iterator or enumerator, whatever you like to call it. We get a handle over which we can iterate over the values. You can see that. So in reducer you get an array of values and the key whatever you provided in the mapper, and of course the context object, the carrier of the data, or the you can think of context as like a big surveyor belt on which conveyor belt, not surveyor belt, conveyor belt on which we'll keep on putting our data, and it will carry the data to Hadoop from our code. Or Hadoop will gather the data from the surveyor belt and then start sorting and churning. All right. So here in reduce we were given key and the array of values by Hadoop. So basically between your mapper code and your reducer code, the only thing has happened is all the values have been grouped together. Whatever was there in your reducer, or whatever was there in the mapper, that has been grouped, and that's the only job done by Hadoop for you. Hadoop took your Hadoop took the file name from you and then created line by line input for your data, and then passed that in line by line to mapper. And after your mapper has given the key value pairs, it has grouped them together, and after grouping all the values for a key, it is calling your reduce function for each key. You can see that clearly, that for each key your reduce function is going to be called, and whatever your reduce function wants to do, it can do. For example, we are gathering all these values and computing the sum. Sum equals 0, and then for all the values in this, sum plus equals to the value, which means we are incrementing sum with that much. Alright? So this way we are computing the of each word, sum of each value for each word, which means we are basically counting words. Alright, once we are done counting, we give the key and we create again long writable kind of a wrapper in which we put our sum and then send it. Now you can see clearly that it is up to our code whether to create any call this function or not. Similarly, it's up to our code whether to write anything to context or not. Okay, if you don't write, nothing will go to Hadoop and so on. Alright, so we have written mapper and reducer. Now third class is driver. Driver is somebody who ties the reducer and mapper together. We have to tell Hadoop that hey, this is our mapper and this is our reducer. That's what we need to do. So we need to kick in the process basically. That's what the role of the driver is. So if the input is other than text, is the same mapper used? Not really. You will have to change the data type in your mapper if the input type is different. I'll show you that part. No worries. Okay. So not necessarily you will get the in input the key value pairs that way. Okay. So here the important part is, so before you start working on this, so you have created a mapper, you have created a reducer, and you are trying to create now a driver. Driver is nothing but basically we are tying things together and making it ready for the execution and then running it. So we create an object called job, and we tell job that hey, your name is word count. In case somebody sees the process, show it as word count, and and this is your mapper class, this is your reducer class, and this is the output keys data and the various data types we provide here. Okay, and we also tell that this is your input folder and this is your output folder. You can see these lines here. This line basically, This line basically tells the job that your input path is this. Okay, and this tells the this tells the job that your output path is this. Okay. After this, we say that job dot wait for completion. It will wait for whatever job is running, and this line basically runs your map reducer. This line basically kicks your map reducer. So while launching your program, you will tell Hadoop that this is my entry point. Okay, stub driver is your entry point, and stub driver will actually launch the process of MapReduce. Okay, and then why do we do system exit? Because because it, because unless and until all the threads exit, Java program does not exit. Therefore, it makes sense to exit a program sometimes by using system.exit. Okay. Input path may be directory or file. That's correct, Srinivas. Alright, so this is clear to everybody. Now, once you have written your map reduce in Java, export the jar, copy this jar to Hadoop server, and you don't have to copy this jar to HDFS, only the Hadoop server, wherever any of the nodes, and run it using this command. Okay, run it using this command. Alright, so let me try to run it for you. So here is my code. I say, and there is an export. You can see somewhere there must be an export. Yeah, we say jar file. We provide its name. You can type any name. Let's say I'm typing my mr something, and then select that folder. Alright, say next, next, generate manifest file, that's okay. And main class you don't have to provide generally. So let me first save it. Looks like I've not saved it. Alright, so export jar file, next, done, and let me change the path to mymr, then finish. Alright, so it's getting saved under downloads in mymr.jar. Note that place. Last screen, Basraj, which screen? Export details, okay? So here you say export, then you say jar, okay? What are the so we have not selected much, we just selected the default one, okay? We just tell that this is my code, so whatever needs to go in the output, okay? And then we say compress the content, it doesn't matter much, and then we specify this, and then we say finish. Alright. Okay, so once we have done that, now is the time to copy it from my laptop to one of the servers. So I say scp. If you are on Windows, you might need winscp command to copy this. Okay, scp, and then what do we call? Downloads, and then mymr.jar. Okay, let me first check what's going on here. So ls minus l, so this is the correct one. So let me just copy it, scp, and once we have let me just copy it to student student at hadoop1 dot nobigdata dot com slash asgiri. All right. So I'm basically copying my mr.jar from local to there. It's asking for password. Done. Now let's log in. I would log into Hadoop 1. Did I do the right thing? Student at no big data SSH. Alright, so let me check in the asgiri folder locally. Is there? Yes. And my mr.jar. This is today's one. I think yes. Oh, because it's in a different time zone. That's why it's saying May 15. Now, the way we execute it is Hadoop jar my mr.jar. Now, the moment we do it, it says that okay, it says that please also provide something called main class. Okay, main class is what? The entry point. In case of our code, what is the entry point? You can say our driver is the entry point. Driver is in a package called sg and stub driver. Yep. So Basrad's point is, didn't we set up that in driver class? So we so driver class sets that okay, let me put it this way. Driver class tells that this is my mapper, this is my reducer, and now run. Okay, but to Hadoop we have to tell that where is our driver class, or which one is our driver class. You can create any driver class. Its name could have been anything. Okay, its name could have been anything. That's correct. All right. So we can say sg dot my stub driver. What was the name? Stub driver. Okay, now it has executed our program, and our program, which is the driver, it says here if the argument length is not 2, that means give this error and exit. And what does the out this say? It has to have one argument, the first argument as the input path, and second argument is the output path. Okay, so first argument is the input path. So my data I know already is lying in asgiri input and asgiri under word count. There is a folder called word, word count. You can check if you want. There is a folder called under asgiri. There is word count, and then there is input, and under asgiri we have word count, and then we can create our own input and we call it output 2 may. Okay, and let's see if it runs. Because if you provide some existing folder, it should give an error saying already exists. So it already exists. And so what should we call? We call put a J. So now the process has started. You can have a look at what's going on by copying this URL. Okay, you can by copying this URL and putting it in the browser. You can see exactly on the URL as well that what's going on. Done. So it has basically saved the output in the output folder. And what was our output folder? Our output folder, yeah, here. So we can say Hadoop fs minus ls. So you can see there are two parts, part 0 and part 1. Why is it so? Because here we have said total number of reduced tasks is 2. Had we said total number of reduced tasks is 3, which means there could have been 3 reducers, and therefore it will basically create 3 parts. Alright? Everybody clear about this? That's correct. The driver class is necessary for each MapReduce program because it's like it's like entry point saying this is my map and this is my reduce, this is my input file, and hence launch the whole thing. And once you're done, tell me so that I can take some action. Okay, so so let's have a look at what's going on here. Okay, so we can say Hadoop fs minus tail. Minus tail basically gives the last 10 lines. Okay, so it has done the work. All right. All right. Any questions still here? Now, so there could be one more complication. Imagine, imagine that your program depends upon, imagine that your program depends upon some other third-party library. Okay? Your program depends on some other third-party library. Okay? And you want to utilize that. Okay, which means your third party library has to be sent to all the nodes which are running in the cluster, and you can do that by using an argument called minus libjars. So basically after minus libjars you can provide the location of all the jars comma separated. Okay, like this: path to first jar, path to second jar, comma 1, comma 2, comma 3. This is equivalent to basically saying minus libjar this. So we'll execute Hadoop jar my example.jar, and this is my driver, and then we have jar's path. Okay, this way makes it possible to run any code. Say for example, so now this was the most simplest code you could have. Okay, your Java code could do anything which any Java code can do. Your MapReducer code can even call database. The MapReduce code can connect to the internet, download some website, and do a lot of stuff from there. So MapReduce code can connect to the database using JDBC driver, which means that you would need to provide the JDBC driver to your MapReduce code. And in those cases, there could be multiple libraries, maybe 10, 20 libraries, which you might have to provide to Hadoop. And in those cases, this libjar argument is used. So you tell your libjar that this is my JDBC library, this is my Java mail library, this is this is that, and hence now run it on multiple nodes. So these jars again will be put into distributed cache and distributed all the nodes which are running the MapReduce. Alright, so this is clear to everyone? Okay. Alright, so you just observed that while writing the Java code, the process of testing is really, really huge. Like, first you have to locally compile it, then you have to create jar out of it, then you have to ship it to your server, copy it, meaning SCP it, and once that is done, you have to test it on the server. Alright? Although all of these steps can be automated, but still the time taken to transfer the data from locally to the remote will be huge. And if your whole development cycle is bad, if your whole development cycle is really, really bad, then if your development cycle takes long time and is not really optimized, your ability to do lot of experiment and hence your ability to write really robust code goes down. So the better the development code, the faster the development cycle leads to a better code or better product. Okay. Therefore, this current mechanism where the current mechanism where we are first you know, exporting the jar, then copying the jar, and then running on the server. So can be made smaller by using the test cases. In test cases, basically we there is a MR unit which emulate the Hadoop's behavior locally. So this MR unit takes your mapper, MR unit takes your reducer, and then run it locally. Okay, I'll show you how. So in test cases, you create something called setup. Setup is a part of the test case which basically runs before the test case is executed. And in the setup, we are saying that my driver is this, my mapper is this, and then I am creating a MR driver, sorry, the MR unit driver. You will see this here. Now, step test is here. Okay, so under this, we are first creating these mapper drivers instances. You can see that. Okay, and we are telling, so map driver is the class given by MR unit. You can see that MR unit here. So map driver, map reducer, map driver, reduce driver, all of these drivers are basically somebody who can run your mapper and reducer parallelly as well as independently. Similarly, map reduce driver execute your maps and mapper and reducer along with some text. So these are the three classes provided by MR unit. One is map reduce driver, which basically runs your mapper reducer, and there is this is reducer driver, which basically runs your reducer. Then there is map driver, which runs your mapper, and which means you can independently test your mapper and reducer as well as test the integration of mapper and reducer together. Okay, so you keep on writing these functions, as you must have known in JUnit, that you create these functions starting with test, or you annotate with @test, and then you write inside that assert true, assert false, or whatever. Okay, so in this case I've just created an example for you. You should create a more exhaustive example. Here all I have done is this. I'm telling MapReduce, I'm just testing the MapReduce driver using MapReduce driver. I'm not testing independently. You should ideally test reduce and map separately. Here I'm testing them together. This is not good enough practice. You have to test both of them independently first, and then you have to test basically this together. Okay. Now what we are telling, we are adding input line rather than adding files. We are adding input line. We are saying this is our input key value, this is our another input key value, and then we give, now on this input please run my MapReduce, and whatever is the output comes here. So we say MapReduce driver dot run. We have already told MapReduce driver that what is our mapper and reducer, and it runs those mapper reducer using this kind of input which we have just given. And once that is done, the output is stored in output. Okay, instead of going into HDFS, it's giving into a variable. And now you can iterate over this, and then check. Okay, all right, so you can say run as and then say JUnit test, and it will run. So it shows that these two have failed because we have written by default to fail, both of them. And here this has succeeded. Okay, because there has been no failure, so this third test case has succeeded. In this test case, we did nothing, we just printed out onto the screen, we have not really tested, and it shows that these are the keys. Okay, so these are the keys. Now you can test whether these here you can say output dot length, output output dot size. Okay, assert true. Okay, and we can say 13. Okay, assert true means, okay, now let's see. Okay, just a second. Assert equals, not assert true. Assert equals. Okay, and yeah, I've added the import correspondingly as it was suggesting. And now let me just relaunch it. You can relaunch from this icon. Yeah, so it has passed. Now if I say 14 here, it'll fail. It'll say you were expecting as 14, but you have got, here it says, uh, the last one, it says expected 14 but got 13. Okay, so this way you can test things. Okay, this way you can test all of this, and then you can basically, all right, so everybody with me on the testing thing? Good, good. All right, so any questions on Java part, or should I move on? No questions? All right. So before, in the first half, when we started the session, we talked about a problem where last line might be broken. Correct? So you can look at this diagram. It shows you there are three blocks: first block, second block, and third block. Okay. This diagram is not equivalent to this one. Okay. So first block, second block, third block. All right. Now in this diagram, there are three blocks. These two blocks are each of the first block and second block, each of are equal sizes, which is 128 MB. The last one is little smaller. Alright? Now, each record, the first block contains four records complete, and fifth record, some part of the fifth record. Each record you can think of right now that they are 5 lines. Each record is equal to line. So first record contains 4 lines in full, while fifth line, say 70% of fifth line, and 30% goes to the next block. Now the next block contains 6, 7, 8th line complete, while ninth block, part of the ninth block and part of the fifth block. Part of the ninth line and part of the fifth line. Similarly, in the last one, last block, you see 10th and 11 are full, while some part of ninth block has spilled over to third block. Alright? So the as you can see that this, if we were feeding blocks to our mapper, it would not give up sensible results. Therefore, on top of this, we create something called input split. Hadoop creates something called input split on top of your data. Okay, an input split is basically a logical representation based on your problem statement. Whether you want to whether you want to access your data line by line, or paragraph by paragraph, or your file is a binary file which has been split into blocks, you want to basically read the whole file at a single node. You do not want multiple parts of it. While processing, say for example, you are trying to compute you are trying to compute MD5 checksum. You are trying to basically generate a signature for the file, and generating the signature such as MD5 hash or SHA-1, you require the whole file at one node. In those cases, the multiple blocks will be brought together, and then the checksum will be computed. So it is very clear that we require a mechanism, an abstract layer on top of our raw data. Raw data means blocks. We need to create some logical representation based on our problem statement, and that is called input split. Okay, on the on the upper part of this diagram, you can see input split. These are input split, which contains the complete lines. So first input split contains 1, 2, 3, 4, fifth line. Second input split contains 6, 7, 8, 9, and third input split contains 10th and 11th line. Alright? So the way it happens is that when your MapReduce process is run, you tell that what kind of input split do you want. Once Hadoop has figured out that this is the kind of input split you want, it will basically load the data into those input splits, and then each input split basically would contain multiple records. A record you can think of as a single line or a row or other things. Alright? So this is clear to everybody? The relationship between input splits and HDFS block. Alright. Now let's move on. So the input split, as we saw in the previous screen, Hadoop divides input into pieces called input splits. One mapper instance for each of, so input split, you can think of it as say 100 lines, 200 lines, 15 lines, and so on. It's basically a bunch of lines or bunch of other records. Okay, so one mapper instance per input is created. Mapper instance means your class will be created. Object for your class, object for your mapper class is created, and created for each input split. Now this class's method called map will be run against one record at a time. Alright. Now split contains many records. Many records. Okay. And if you try to create a smaller input split as compared to block size, so there is something called block and there is something called input split. Block is something to do with HDFS, okay, the way the data is actually stored and the binary data, while input split is more of a map reduce paradigm, and it's basically the logical representation of your data. Now, now in case you try to create an input split on top of a small part of the block, say for each block you are creating 50 input splits, okay, which means it is going to run parallelly on 50 places. 50 instances of the mapper will be created, and hence it will be fairly inefficient. And also, as you noticed in the previous diagram, that to complete input split, the boundary data, as you saw, the portion of the fifth will be transported from another node to the first node, the second node to the first node. Here there are three nodes: node 1, node 2, node 3. Now, for making the input split a logically proper representation of the data, some part of the second block has to be transported back onto the node 1, correct? And there is a transportation of the data involved. Although it's small here, but if you have, say, input split had been very very small, okay, very very small, so there will be too much of transport of the data, and which is not a good news. Okay, therefore, and otherwise also, if you try to create too many if you try to create very big input split, if you try to create very big input split, that means you are going to you will have to transfer the whole block of the data onto some other node, or all of the blocks of the data for the same file onto some block, onto some other node. That means there'll be a humongous transport. Therefore, whether input split is too small or too big, it's not good. Okay. Therefore, you try to create input split as equal to HDFS block as possible. You try to make sure that your input split is very similar in size to 128 MB. Alright? Everyone with me? Now, input split contains records. In our case, input split contains lines. Each record is a line. The word count example which we took was a line. But it could be anything. It could be a paragraph. Basically, a single record could be a paragraph. And a record is basically given to your map function at a time. Only one record is what your map function will receive. And for each record, if there are a million records, that means your function called map will be invoked that many times. Although the class instance will not be created a million times, class instance is created on one input split at one instance per input split, but mapper function is executed one record at a time. Alright, now let me see, there are some questions. So Kalyan, which part do you want me to clear? So Manishi's question is, can we configure input split? Of course we can configure input split. We can configure from here job.set input format class. Okay, using input format class we can define our input format, and that will govern what is our input split. Alright, we'll show you that. All right. Kalyan, has it become clear or great? So a input split contains records. A record could be a line, it could be a paragraph, it could be, in our word count example, a record was basically a line, right? In some cases, a record could be a row, database row, okay, and and records are created by something called input format class. We'll show you input format. All right. Now there are multiple kind of input format. Input format is something like an entry point for the whole game. Input format dictates that what kind of records are going to be there and what kind of input split is going to be there. So input formatter is the class which basically enforces everything. All right. So for example, in our case, the input formatter was text input format. We told that our file is text and we want line by line, and therefore we told we are going to use text input format. And text input format is the default format. Okay? If you don't specify one, this is going to be that way. Okay. Now next is that if you want some other delimiter, you can use text input format dot record dot delimiter, and you can specify this delimiter. Okay, if you specify this delimiter as dot, that means instead of new line it is going to consider dot, and therefore our whole text will be broken into sentence by sentence. All right, that partially solves our problem of tuple finding. Okay, that partially solves our problem of churning the data sentence by sentence. Although the dot could come in the middle of sentence also, and dot could come in numbers also, but still, for right now, for our simplicity reasons, we can say that we can control on what basis the text input format is going to prepare the records for you. Will a record be a full line, or will a record be a sentence, or will a record will be maybe say key value pair, and all right. So those kind of things are dictated by input format. Now the second one is n line input format. In case you want to put multiple lines, fixed number of lines per mapper, if you want to enforce that these many lines should go to this mapper, these many lines will go to second one. So basically we are creating each input split of the fixed number of lines. Okay, this remember, this is not optimum. This is not optimum. It's just because of our problem statement. Our problem might demand that we want to we our logic will be only correct if we have fixed number of lines. Okay, in those cases it makes sense to use an n line input format. And we can tell that we are looking for, so you can say here job.set input format, and we can say n line input format. Okay, we have already written it here, so this way. And then we can also say set in the conf one, we can say set, and then specify this argument. We can specify this argument and then the value. Okay, if you want 100 line per input split, we can specify this way. Okay, right, since it doesn't accept integer, we quickly converted this integer into string. Next is fixed line input format. If your each line contains fixed length records, okay, In our example, we have always seen that our lines were separated by new line, correct? Or our record were separated by new line, and we were tackling in them. But sometimes our data is not based on separator. Our data is based on fixed size. That from 0th to first 100 character, it is going to be this particular field. Then from this to this is going to be this particular field, and so on. There is no concept of line in some data types. Okay, so it can be binary, it can be anything, and generally this fixed line length input format, is good for some database files where you store each row into each record, and so on. Okay, we leave the padding for each record to come, and so on. So fixed length input format is good in the cases where record is a fixed size. Now Kalyan's question is, suppose we are using n lines input format, then what is the size of the block? Size of the block is remain same. It'll remain same 128 MB. It doesn't impact size of the block. Okay. Suppose if we give Kalyan's question, suppose if I give input split as n line, and the size of the split is more than the RAM size of the particular node, in that case what will happen? Okay, that's good question. So yes, so those are the challenges. In those cases you will get a memory overflow exception sometimes, because Hadoop does not really load everything into memory for on each node. Okay, it tries to load partial data and then churn it. But yes, there are chances of overflow. If in your map code you started loading the data into memory, then there are high chances that things will break. Okay? Srinivas Kalyan, is that clear? No. Good, good. Now there are other types is also here you can configure like this. Using conf object you generally set all these properties. Now sometimes your data is in key value pair. If you remember, our mapper was taking key value pair anyway. Suppose your data anyway is in the form of key value pair. In those cases you can use key value input format and also define what is your key value separator and what is the separator between one key value pair and other key value pair. So all of that you can define from here. Okay. Now there is something interesting called sequence file input format. What is sequence file input format? Sequence file input format is for reading a sequence file. And what is a sequence file? A sequence file is basically flat file for binary key and values. So this kind of data where, so okay, let me take a step back and explain you the problem statement. So in case of HDFS, the small files are really big pain. The smaller the file and the more number of files, the more metadata it would consume. Okay, imagine that there are 150 files, each of size 1 MB. Okay, these 150 files will consume metadata equal to metadata equal to a lot of metadata actually. Okay, lot of metadata, and because for each file you will have one block, right? Although block will only consume 1 MB of disk space, but the name node will get really bulky. Okay, now what if in some cases you have to process hundreds of such files on a single node. Okay, hundreds of such file on a single node. That means if one file's block is on one node, another file's block is on another node, and so on. If you want to process multiple such files together, it is going to consume a lot of time because the data has to be transported from all these files onto single node. Okay, and therefore the wisest thing to do in these cases is to zip all these 100 files, which are very small 100 files, and then convert that zip file into sequence file input format. There are tools which you help you convert the zip file into sequence input file, and then you can load it. You can load it as if it's a bunch of key value pairs, which means each file will be represented as key value pair. Key will be the file name, and the value will be the content of the file. Okay, so this is a clever strategy of handling too many small files. Okay, so you can have a look at what does it look like and what's there in the format and so on. Okay. Alright, if in case inside the mapper you want to load the data from HDFS, you can do that too. Right now in our example, before launching our MapReduce job, we are providing the input folder and input file, correct? What if our HDFS, our map and reduce logic, we want to access the HDFS? In those cases, you can use this class called file system class, and I can show you quickly that it does really. Srinivas, for which one? This particular case? Yes, I can give you. You mean why would? All right. So you can see that we have file system, and we can say Hadoop file. Note that this has to come from Hadoop. Okay. Do not do not try to. This is JavaNet, and this is something like HDFS and say user slash student slash sgiri slash some file dot txt, like this. So here you can basically all right, yeah, this is good enough. All right, so we can say context dot get configuration. Okay, so here you can provide context.get configuration, and then we can start loading the file. Okay, we can say copy from local and whatnot, although these are static. Okay, so you can say get block locations. Okay, you can do anything what you want to do actually. All right. So yeah, conf object is from context, and then you can read the file and do whatever you want. All right. And not only you can access a file, you can also, using the same file system object, you can also create folder onto the system. you can delete from here. So you can basically manipulate the whole HDFS using file system object. Okay. All right. So yeah, coming back to the question of Srinivas, who is saying that can you give a real example? Let me try to give a real example. Okay. Now let's talk about a scenario where basically from one mapper we are trying to read some data from HDFS. So say inside the driver, or how should I think about yeah, let me think of a little bit more clever ways of explaining. All right, all right. So in the map driver, for example, in the map driver itself, we are trying to figure out that whether we should be running multiple reducer or a single reducer, or what should we be doing. Okay. In those cases, we can quickly examine the HDFS input file from here, from the step driver, that how big is our input file. Okay. And once we have figured that out, that how big is our input file, we can create that many number of reducer in the driver. All right. So those are the few use cases, and there are many such use cases. Okay. The other thing is for there are some zip compression formats which are which are okay to split the file, which can happen on partial data. One such input type is aljado. Aljado compression can be applied on chunks of the data. Aljado compression is fairly tolerant to the split of data. So if you remember correctly, that when we so I'm sorry. So have you ever used zip file and have splitted a zip file and tried to unzip individual files? And you cannot generally unzip individual parts of data in case of normal zip, correct? But in case of our HDFS, where we are trying to store our data into HDFS, we would require a compression such that the data individually, also each part of the compressed data can be uncompressed easily. In those cases, you could use gzip splittable or Hadoop Aljado. Both of these projects are for those cases when you want to store your data in a compressed format and you want to uncompress each block independently. All right. So this is general overview of classes. So the entry point of the whole game is input format. A input format basically gives out two things: get split and create recorder. If you want to create your custom input split, if you realize that none of the existing solutions are doing a good job and you want to create your own input format, then probably you will be using MapReduce input splits. Okay, you'll be using input format and input split. So the first thing which you will implement is you will basically extend input format class and provide your record reader, and then you will implement your record reader. And generally you can also extend input split class. The by default input split class has to provide length and the location of the data. Okay, you can implement your own also by extending input split, right? Okay, Srinivas's question is that which input splits are useful for video file? Okay, so my first question is that what do you want to do with the video file? Okay, so the have a look at the sequence file. Most of the binary files, wherever you want to churn the whole file in one shot, the fixed format or the file sequence input format is the one which will come to use. Okay, in most of these. Storing video in YouTube while running online. Okay, okay. In those cases, a better way would be you just store the no it's like a binary file. Okay, you store it just like that, but you write your own reader. Okay, because it's a binary file and you want to read one block at a time, you will have to write an API to retrieve the data and then present to the web interface. Okay, so you will not have to create MapReduce for this. You will not have to create basically input splits. Here what you need to create is your class which can read from HDFS a video file and then display it to the web interface. Make sense? To analyze the frequency of common words used in the videos file. Okay, okay, that's interesting. That's interesting. So the question here is we will have to create splittable video files, which means that if we are given a handle to the video file, the parts of it, we should be able to play it separately. Okay, I need to find that out, that what will be the, so basically Baswara's objective is to be able to churn the video file one part at a time. Okay, using MapReduce. In those cases we'll have to figure out how can we split our video file such that each part is each part of this video file is basically individually playable. Okay, so we need to find that out. Correct. And similar is case with the yeah, that's very good use case. Thank you, Srinivas. So yeah, that's an interesting part. So imagine that you're looking for somebody's face and you have got say 20 GB or 30 GB file. Now Now imagine that churning some 10 MB of such video to match a particular photo takes around 20 seconds. Now, if you try to run, this against what we are trying to do, for the full file, it is going to take a long time. So a better strategy would be that we split the video files such that each individual parts can play parallelly. So one node can run the video from 1 to 10 minute, the second can run from 10 to 20 and so on independently parallelly. So how can we split the video file? Which input split we should use in such case is something I need to figure out. I haven't used it yet, but that's a very good thing to do. Okay. And there are lots of video analytics use case. Like for example, the football match. People have tried to do a lot of analytics on top of football match. All right. So we will look into the video analytics, video how to split that maybe tomorrow. and we were where we were. Yeah. So you can extend the input splits, and in the input split you can basically customize it. I have written an example. You should, if you have time and are inclined, you should go through the custom input splitter. The idea is extremely simple. It's just that to implement it, it's difficult. So imagine that there are, let me just take it, and I hope you will stay with me for a few more minutes. Okay, just a second. So, yeah. Alright, now you can see that this is our file. Okay, now on this is on first node. This is our first node number 1. This is our node number 2, and this is our node number 3. Correct? Which means on these three nodes, the processing of each input split will start parallelly. Okay, so the first node, let's say that it starts from here in the beginning, second starts from here, and third starts from here. So all these three nodes are trying to read these three different blocks of the same file parallelly. Okay, now what would happen is, in these logic of input splitter, the input format, or you can say create this you can say here, the create record reader, the create record reader does a lot of, because create record reader is being executed here, here, or here. The record reader is trying to create records out of this block data. So, and it's the same logic being executed parallelly on three different machines. So what does it do exactly? So on each node the logic will be like this: keep on skipping the data, keep on skipping the data. Either either you did not start from the beginning of the file. In case you start from the beginning of the file, do not skip the data. Second, if you did not start from the beginning of the file, that means you are somewhere in the midway, which means you might be in the second block, second one. Okay, if you hit the beginning of the file, that means you are on the first block. If you are on the second block, which means you did not start the first byte you read, you realize that it was not from the beginning of the file. Okay, that means you are on the second block, which means you will have to keep skipping the data. You'll have to keep skipping the data unless you hit a boundary. Boundary means, in our normal case, boundary means /n. The moment it hits the new line, it will stop skipping the data, and then it will start reading the data. And same case is happening on the third block. Exact same logic, that it will keep on skipping the ninth block unless it hits the boundary. Boundary is new line. Okay, so all 1 2 3, everywhere your same logic is running, and your logic says, if your location is not 0, okay, keep skipping unless you hit a boundary. Okay, that's the logic. And similarly, you can also create your own input splitter saying keep on reading the data unless something happens, or keep on skipping the data unless something happens. All right, so that kind of, that way you can basically create your own input splitter. All right, now how does node identify what is the starting of the file or not? So the file seek pointer gives you the location of the character. All right, that could tell you clearly that you can, the project which I have given you in this session, if you go to my courses and see this today's session, session number 5, you will see all of these details over there. All right, now in this itself, here, I have written a custom reader here. I defined something called my input format, and then which extends some other input format, not directly input format. This guy might be extending input format. So text input format might be extending input format, and so on. Now in this I've said create record and return this one. This is what I've created here, this one. Now in this we keep on in initialize we keep on skipping the data. See, skip first line true. We keep on skipping until we hit a boundary. You should look at this detail, this code in detail to understand how does it really work. Okay. So here you can also see that split.get start. If its start is not equal to 0, which means we are not in the beginning of the line. Alright? That answers your question. Alright? So have a look at this code if you get time, and then we will again discuss few more things. Okay? Hope everybody is clear about single reducer. This diagram is clear to everyone? Is this diagram clear to everyone? Alright, great, great. And this one? So now you see this input split, what does it mean? This is input split, you see? So instead of talking about blocks, we were actually dealing with input split from earlier. I just kept on avoiding it so far. Okay. So on input split, we create a single the instance of the map. Then for each record, we run map function. Map function gives out key value pairs. Those get collected here. Then they are taken to the reducers where they are merged together. And then on each key we run the reduce function on all the values. All right. Then we see you tomorrow and have a good day. I know I have run 9 minutes more. Okay. All right, thank you, Srinivas. Thank you very much. And yeah, if you guys write a blog or something, you let me know. You can write blog for us, and you know, we are looking for people who can write a blog. Okay, maybe somebody who can basically even summarize this discussion on a blog. It will be great. So let me know if you're interested. All right, see you tomorrow at the same time. All right, bye bye. Have a good day. All right, so let me just end the meeting. Bye bye. See you tomorrow.